July 22, 2025, a new chapter in our understanding of the universe begins. Deep beneath the Swiss-French border, scientists have just collided protons with oxygen ions at the Large Hadron Collider. This isn't just another experiment, it's a leap toward answering the biggest questions about our origins and the fabric of reality. Imagine a controlled echo of the Big Bang, unlocking secrets at the smallest scales. For years we've smashed protons into protons, and lead into lead. But this new collision, proton with oxygen, opens a fresh window. It's a new key to a hidden door, revealing forces that shape existence. The data from these collisions will fuel discoveries for years, possibly reshaping our understanding of the Standard Model. This achievement is the result of decades of global collaboration and relentless curiosity. The LHC stands as a monument to human ingenuity, recreating the universe's first moments. We're not just looking back in time, we're dissecting the building blocks of reality. What we learn here could change everything, revealing new particles or phenomena. Today we step boldly into the unknown, beginning a journey into the very fabric of the cosmos. The Large Hadron Collider, humanity's most powerful particle accelerator, sits in a 27-kilometer tunnel, 100 meters underground. It accelerates particles to near light speed using superconducting magnets colder than deep space. These particles race around the ring, gaining energy with every lap. At peak energy, they're steered into collisions, where giant detectors capture the aftermath. Each collision transforms energy into showers of exotic particles, revealing nature's deepest secrets. The LHC is a time machine, recreating the universe's earliest moments, a hot, dense quark-gluon plasma. By smashing particles together, we glimpse the birth of matter and the forces that shaped our cosmos. It's a symphony of technology, pushing the boundaries of what's possible. Why collide a proton with an oxygen nucleus? It creates a unique intermediate system, bridging the gap between simple and complex matter. This experiment lets us probe the quark-gluon plasma with unprecedented precision, using the proton as a clean probe. We can map the oxygen nucleus and study the strong nuclear force that binds atoms. The key question, does this plasma behave like a gas or a perfect liquid? Proton-oxygen collisions will test this in a controlled way. By analyzing the emerging particles, we refine our models of the early universe. We also explore the transition from confined to deconfined quarks and gluons, the phase change of nuclear matter. It's like watching water turn to steam, but at the subatomic level. These insights reveal how matter is organized from the smallest particles to the stars. This is fundamental science, unlocking the rules that built everything. The impact of this collision reaches far beyond the LHC tunnel. It echoes across the universe. Ultra-high-energy cosmic rays, slamming into Earth's atmosphere, collide with oxygen, just like in the LHC. By simulating these events, we decode cosmic messages and trace their origins to supernova or black holes. The experiment also illuminates the universe's first moments, showing how complexity emerged from simplicity. Studying how particles flow together reveals the conditions that shaped the cosmos. This is science at its most profound, connecting the smallest scales to the largest. Each collision peels back another layer of reality, hinting at new phenomena or deeper truths. The first proton-oxygen collision is a leap into the unknown. The universe is still full of secrets. Our spirit of exploration is the key to uncovering them.